So for the first question, a lot of you actually tried to calculate it, which is perfectly fine, but I'm going to show you a way that's a little bit faster. And so what they're introducing you here to this expression at the top, or this equation at the top, they're introducing you to a binomial that is squared. So squaring a binomial. And you guys know what a binomial is in algebra. And they're basically saying that if you take something and you add something else and you square it, you will get this answer here. If you look at this and compare it to what they give you, what you're going to notice is that the A is 1.6 and the B is 0.4. And then this part, again, 2AB. So to get K, really, all we need to do then is use this part of the equation, where A plus B squared is going to equal the answer. And if A is 1.6 and B is 0.4, and we add that and square it, we get 2 squared, which is 4. So that's just a little bit of a faster way than actually having to calculate that whole equation. If you calculate it all, that's totally fine. So let's look at the second one. So what you're going to notice in the second one, there's a whole bunch of different ways of approaching this question, and I'm not really sure that one is better than the other. But remember that math is all about patterns. And so what you're going to notice, one thing to notice, the smallest number, oh, hold on one second. Sorry, I circled the wrong thing there, so let me go back. So you're going to notice if I circle the smallest number on each row right here that you're given, 6 is 1 more than 5. 11 is 1 more than 10. 16 is 1 more than 15. 21 is 1 more than 20. And 26 is 1 more than 25. The smallest number in each row is always 1 more than a multiple of 5. So that is something to keep in mind and use. So 2015 is the smallest multiple of 5 that's closest to 2017. And that means that if we use this pattern, if we add 1, we'll get 2016. That will be the smallest number on whatever row it belongs with, and it will belong with the row with 2017 and 2018 and so on. And so the smallest number that will be in the row with 2017 is going to be 2016. So let's look at the next problem. Most of you did get this one right. You were able to recognize it as a Venn diagram problem. Again, there's other ways of doing it, but most of you recognize that 32 plus 40 equals 72 people. So if you're serving 45, that doesn't quite make sense. And so you were able to recognize that if you did 72 minus 45, you would get 27. And that would be the least number of students that would be taking both. So that I have in a Venn diagram, remember that's where you have 27, and then this circle is the algebra circle, let's say. So you have 13 there, and this circle is the Spanish circle, and you have 5 there. And in total, we have 45 people. And that's the smallest number. If you had more than 45 people, like say there were 50 people, that's where you have, you're in your Venn diagram, you have this empty space here where you'd put those extra people, and that would be the number of students taking neither one. But this was asking what is the least possible number of students who are taking both, and so you want to have 0 outside, and that would be the way to do it. So 27 students is the least number taking both. Now this one here was a little bit challenging for people. And probably the best way to approach it is to kind of do a bit of guessing and checking. So, for example, the smaller square could have a side length of 1, an area of 1. The smaller square could have a side length of 2 and an area of 4. So this is side length, this is area, and we're kind of making a table. It could have a side length of 3, area of 9, 4, 16, 5, 25, etc. Then what it says is the L shape is 21. So we know then to get the larger square, if the smaller square is one of these numbers, to get the larger square, we just have to add on this L-shaped 21. So let's see what happens when we add 21 to each of these numbers. So 21 plus 1 is 22. This one is 25. That one is 30. That one's 47. That one, did I make a mistake there? I think so. This one is 37. What you're going to do when you start to have these numbers is you're going to start to examine them to see, are the numbers in green potentially the area of this bigger square? And remember that area of a square, they have to be perfect squares. So 22 isn't going to work. 30 isn't going to work, but 25 is a potential area for that larger square. So if you kept this going, so I'm going to pause this and just fill it in quickly so you don't have to sit here forever. You're going to see what some of the other numbers are going to be. So there's some of the other numbers, and again, if we use that same strategy, there is another perfect square. So now the question is, what do we do with that? Well, that means your answer is that and that, the sum of the two possible lengths. So we found the two possible lengths that might work for the smaller square. Now we have to find their sum. So the answer for that question is 12. This last one is a really, really neat question, and there's lots of different ways of approaching it. But the fastest way of approaching it is to use something that really is not kind of taught formally until grade 11, 12 maybe, but it's based on, sort of based a little bit on factorials that we did in grade 8 as part of that 1 to 100 assignment. What you're going to do is set up a 4-digit number. You know that the 1 and the 7 have to stay together. So there are some possible places you could put it. You could put the 1 and the 7 there. You could put it there. And you could put it there. That means there are other numbers that could go in the green and the blue. So now you have to start to think about what could go where. What are some of the possible numbers that could go in each of these spots? Well, in this spot, I can really use any number from 0 all the way up to 9, because all of those would work. From 0 to 9, there are 10 digits. I could also use 0 to 9 for that one. This means I just do 10 times 10, and there are actually 100 different numbers that would work in those combinations that start with 1, 7, and then have, so it could be 1, 7, 1, 0, 1, 7, 1, 1, 1, 7, 1, 2, 1, 7, but there's too many to go through each individually. So this is a really quick and easy way to do it. You can do the exact same thing for this one, except this one's a little bit different because the leading number can't be a 0. You can't start a 4-digit number with 0. So our leading number has to be, there's only 9 options because it's 1 through 9. Your end number, there are still 10 options. So there are 90. And then this same thing, you can't have a leading 0, and so there are 90 there. Or, yeah, 9 times 10 and 90. So that means we do 100 plus 90 plus 90, and we get 280. Now, the only problem, the only thing we now have to consider is that this one here and this one here could both result in 1717. So we've actually counted the 1717 for this one and for this one, but we can't count it twice. So we need to take away 1, and our answer is 279. If you have any questions about this or you want to go over it with me, just come and see me. I'm happy to go over it with you.